Good morning, ladies and gentlemen, here physically in our very, very nice facility, but also online virtually. We would like to welcome all of you, wherever you are on this planet, to our panel discussion. So, as Daniel already mentioned, we are going to discuss about strategies, trends, perspectives of battery manufacturing. And of course, what can you expect? We have a series of experts here on our panel. I'm going to introduce them to you. And as you already have practiced throughout the day yesterday, please drop us your questions so that we can see which has the highest priority for you to learn about. And then we are going, after our experts have shared some precious insights, we are going to address the questions to you. Okay, so who is sitting here? And we will start from the right-hand side. So on the very right-hand side, we have Dr. Dominik Lemke. He is Director, Product Development at SVOLT Energy Technology GmbH. And he has also shared an opening statement that we are going to elaborate on with us. And Dominik, he states, both the regulatory level and the limited availability of raw materials make the recycling of electrical vehicle batteries imperative, and at the same time make it unavoidable to consider the sustainable life cycle holistically. So we are going to talk about recycling and of course also the shortage of materials. So warm welcome here, Dominik, here on stage. Next, we have Dr. Dirk Abendroth. He is the CEO of CUSTOMCELLS Group, and his statement is manufacturing. Manufacturing is the key driver for battery cell innovation. We are also going to address this with you. You are going to elaborate on this, Dirk. Okay, so then we have Mr. Nemanja Mikac. He is the CEO of 11Es, and his statement is that a key factor for having a higher success rate of gigafactory deliveries is the ability of battery cell manufacturers to de-risk and to scale up production, both things together, which is done through several incremental stages of development, from the R&D lab over industrial pilot to mega factory, and then finally to the gigafactory. So definitely de-risking and ramping up at the same time. And then on my right-hand side, I would like to introduce to you Mr. Sebastian. He is the COO of PowerCo, and his statement on the subject is, producing battery cells at scale is a completely different story, is a completely different game than producing high-quality batteries just on an R&D line. So many of the emerging players in Europe, they underestimate the challenge of industrialization and will struggle to succeed. Okay, so we have a series of very important perspectives. And I have already emphasized the aspect that Nemanja has shared with us, the aspect of de-risking on the one hand side, but also ramping up and also the incremental changes. Could you maybe elaborate a little bit on this, focusing of course on the 11Es products?
Yeah. Yes, absolutely. So I will talk more in general because this is more of educational nature. So yeah, there are many companies and many startups, many universities, as you know, making different technologies, and it's all great and we all need that. But then when it comes to mass manufacturing, it's actually a different game. So the companies need to find a way how to de-risk the whole process, and in the beginning it's not about really profitability, it's about how do you save money in the future by learning today and by actually making it step by step, that you actually become a successful company within a few years' time.
And how are you going to do this? What are the steps? Because we're talking about strategies, trends.
Yeah, so we have done a really incremental approach. So 2.5 years ago, we've built an R&D lab, and we've basically first learned the fundamentals of battery making on a mass scale, which means learning about the chemistry, how to coat it, what to do, formulations and so on, formation process, how to assemble a cell. Then we went with something called a mini pilot, which actually opened yesterday, which is a facility where we can make a full-scale battery up to 300 amp hour, so pretty much covering the EV, bus, and ESS segment on a relatively cost-effective way. So it's a production site, but it's a first step towards a gigafactory. And then the third step would be a simulation of a gigafactory, which is what we call, I think, one line, which is like then replicating the full scale. And then when that one line works, which is in our case end of next year, then you can multiply that one line scenario into multiple factories.
Okay, so definitely starting from there and then multiplying actually the blueprint, so to say. Is this, Sebastian, also something that you are doing at PowerCo? Is this a similar approach?
Yeah, I mean, ultimately, you always need to look at your timeline, right?
Yeah.
But for sure, we also start with a pilot line, and then we ultimately scale it up. I think we have I think we don't go via mega factory, we directly go from pilot line to a larger scale facility. But I think the key is also to understand what is your supply base. What is your supply base, not only for materials, but also for equipment capable to do, and where do you basically de-risk your ramp up, right? And I think there's a lot of technology around in the space where everybody says, I have completely innovative ideas. I mean, talking about, I don't know, dry coating is something which everybody talks about. The question is, what do you do for your first SOP, right? And I think the first SOP, you need to consider a strategy called safe launch. So you need to make sure the production is really up and running, because if you consider and look at all the other battery cell factories which were ramping up in Europe in the last years, looking at, I don't know, East Europe, North Europe, Western Europe, they all were challenged during the ramp up. So that's why we were considering on purpose to say, okay, we look at what is the most robust one to go in a large scale facility. We also validate our processes before we start mass production. So I think this is a really, really important thing to really get to understanding what is your mass production equipment actually capable to do, and where are the risks also in the ramp up.
Okay, and are you collaborating with specific suppliers of such equipment?
Sure, I mean, there are not too many suppliers around the world which are capable and have proven on really 1,000 equipment per year what they can deliver to really be successful. So I think that's where you need to start off. For sure, you also need to understand where are the innovations, because you shouldn't be decoupled from innovation cycles. But the question is always, where do you start from, right?
Okay, so and regarding the manufacturing footprint, PowerCo, is there something that you could also share with us where the footprint is going to be?
I mean, right now the first factory is in Salzgitter.
Yeah.
SOP will be in April 2025. Second factory is in Spain, in Valencia. And the third factory we actually just announced last week in a public event is in St. Thomas in Canada. So Canada will actually be our biggest facility with up to 90 gigawatt hours of facility. So we're quite a bit bigger than what we start with in Salzgitter.
Okay, so Europe, Germany, Spain, and then moving to Canada. Okay, so I guess we are going also to discuss about this further, and maybe also the aspect of standardization, but coming to custom cells. And I mean, custom cells, the name also implies that there is some customization. Can you tell us a little bit about your approach, Dirk?
Yeah, absolutely. So Custom Cells is a company which actually grew out of a Fraunhofer Institute, so it's a spin-off actually, which has been focusing the last 10 years on a evolutionary growth, especially kind of focusing on high performance cells. So everything which is beyond the mass production, etc., and one by one now gets into a serial production. So we're facing very similar challenges like the two gentlemen on the left, so Sebastian and Nemanja. So getting from kind of a small entity, small economy of scale, and very innovative products into a larger scale, maybe not the scale of Volkswagen yet and all the big ones, but we're facing the same problems. And that's also...
Go ahead.
And that's also why it actually came to the intro statement, saying that in the end, manufacturing is driving the innovation. So you can consider it like, on the one hand side, there's cell innovation, with suppliers, material suppliers, with vendors for machinery, tooling, etc. And then at some point in time, you need to make a certain jump, and you jump into manufacturing, and that to a certain degree always means a certain freeze. Yeah, you need to freeze the technology to stabilize the processes for manufacturing. And then at some point in time, you realize, okay, is that kind of a balance thing? Like, is that a trade-off between being innovative and being, productive in manufacturing? And we think that exactly makes the difference. So my statement is, we actually kind of try to change the people's mindset from saying, okay, first you innovate and then you try to manufacture that, towards saying, okay, think the innovation from the manufacturing device point, because that's the only point of truth. So very simply speaking, innovation doesn't happen in the lab. Innovation always happens on the line. So that's the key statement.
And the process, how do you do it? So, I mean, really the innovation process, because normally we would have innovation, engineering, and then we would, go into work preparation, and then we have the manufacturing process. And you say manufacturing is actually where the music plays, and then you are sending the information back into innovation. Tell us a little bit of the secret about it.
Yeah, well, I guess the key thing about this is, very simply speaking, our heritage. So our heritage is that we finally grew out of a very, very big, horizontal integration. So we covered everything from PowerPoint, first ideas, getting into the chemistries, developing, designing cells. And then here's the key point. Once this is on the table, we need to develop every single manufacturing step first time for everything which is new. Yeah? And that is what we usually kind of do completely in one row as one package for the customer. So that's what we did for more than 10 years, for Formula One customers, for bespoke customers in industry, but also in aviation. Yeah. And now one by one, exactly this, say, complete chain of horizontal and vertical integration is what we currently use to think back from the manufacturing at the end, back towards, okay, what do we need to change in the design?
I see. And is there also some, let's say, cross-industry learning? Because, I mean, you referred also to aviation.
Oh, yes, absolutely. So that's something which at the first point in time, you might think like, okay, automotive is light years ahead of aviation in terms of electrification. And that is absolutely true. But on the other hand side, there's a couple of side effects which we are currently looking very deeply into. So one example is that once you move into aviation, you always need a certification, let it be EASA or FAA. Now there's a very, very high safety requirement, and you need to track back every single battery cell down to the materials and even down to the mines. That's the minimum you need to have, and safety track record of every single cell during operations. So that finally gives back a pretty big digital side product, which is, say, mandatory. And this digital side product, it's actually something you develop actually in parallel to the physical cell. And that, at the very first glance, might be not necessary for automotive, but I promise you, once it's there, you want to have it.
Okay, good. So, I mean, we have talked about the engineering path and also starting from the line and then scaling up. Something that we did not actually cover so far by the three remarks that you have shared is what actually Dominik has shared with us. So the regulatory level, but also the limited availability of raw materials, and also the recycling aspect, which of course plays a crucial role. And maybe you can share your viewpoint on this, the recycling aspect, Dominik.
On the recycling aspect?
Yeah,
I mean...
on everything.
Yeah, on everything, okay.
Yeah.
So I start with everything and then I come to the recycling aspect. Yeah, so first of all, it's a pleasure to represent SVOLT today here in this round as a Chinese battery supplier, maybe a little bit an exot in this round, but I'm happy to add our point of view. First of all, the situation in China is a little bit different, right? So depending on how you look on it, China, the Chinese battery industry has an advantage of 10, we just discussed maybe even 20 or even longer time. So we in SVOLT in China and also other battery suppliers, we have developed this. So we have a substantial footprint in China on gigawatt hour scale of production. So we have a deep knowledge of the technology. And when you look on the sources of the raw materials, I mean 90% of the materials, constituents, cathode active material, etc., is produced in China. So all of these things, I would say, for a Chinese battery supplier are not of an issue. So for us, when we look about how to transfer this to Europe, the challenge is completely different. The challenge is more a cultural thing, right? So we have to build this bridge I mean, everybody who went to China and took a taxi from the airplane, from the airport to the final destination knows what I'm talking about. So it's a completely different world, right? And this influences everything. It influences the way they make business decisions. It influences the way, you know, what's the time scale to ramp up a production facility, etc. pp. Your communication, and the real challenge lies in, you know, bridging this gap and transferring the knowledge and the value chain in China to Europe. Coming to the recycling point. I mean, I like this analogy. So recycling, when we say battery recycling, most people think of maybe plastic recycling. So when you look at plastic recycling, so the question is, I mean, what rate in our plastic, in a plastic bottle, what is recycled? And it's actually very low, right? So I don't know the precise figure, 5 to 15% is maybe recycled plastic. And the reason for this is twofold. So first you have a product which has lower quality, so it's a degraded product, right? Plus it has a higher price. And who buys this? Who buys a, you know, low quality product for a higher price? So in terms of battery, it's a little bit different. So you can, I mean, we could start a panel discussion on recycling processes. It's a very broad topic. But in the end, you can implement a recycling process which delivers you the raw material, the nickel, the cobalt, the lithium, on the same quality level with which you can build a cell with the same quality grade as a, you know, battery cell produced from raw materials. So this is not the issue. The issue is it needs to be cost competitive, and it will be cost competitive once you consider also the CO2 footprint of the recycling processes. And I'm pretty sure when we look in the future, also considering the EU battery regulation, where there's a real attempt to consider the CO2 footprint in your raw materials and giving this a fair price, that in the future battery recycling will take off and will constitute to the material supply in the battery value chain.
Okay, so the aspect of materials and recycling is also something that our audience has raised here. So, and I mean, it is quite generally phrased. Are you working on other materials for batteries? And maybe you can talk a little bit about the materials that you are using, yeah? And also if you are thinking ahead, if there might be some other materials, right? So maybe Nemanja, you want to start?
Sure. I mean, we decided to focus and scale first, so we're focusing on the LFP chemistry. And
can you explain LFP?
Yeah, of course. And the versions thereof. So it's lithium iron phosphate. That's a cathode chemistry, which is one of the most important distinguishing factors in a battery. The other one will be the electrolyte. That's why you hear about solid state, but and the anode as well. But going back, it's basically a little bit. It doesn't have nickel and cobalt, so it's a little bit more affordable. And it's made for the entry-level segments. It has a slightly shorter range, which we overcome by using some other technologies called cell-to-pack, but it's for another panel. But essentially, everybody here kind of found their niche and their focus and what they want to do in the next couple of years. Of course, we have variations on the topic, so slightly longer range, slightly faster charging, you change some things, and then you can get different products. But if you go too broad and you want to do everything, you might lose focus and then you're late for the game. So in our case, it's basically entry-level vehicles, energy storage systems with using LFP cell-to-pack technology.
Okay, very good. So LFP, lithium ion. So yeah, in your case,
I mean, we focus on. We also look at different materials.
Yeah.
So we probably have to cover a multiple range of chemistries, because we are supplying Volkswagen Group, with not only one car, but we have a wide range of cars, right? We call it cost optimized, we call it main, and then we have best-in-class batteries. So for sure, we also need to understand, well, what is going to best-in-class, which is right now is NMC is one of the technologies which we have to look at right now. But for sure, also LFP for stationary, as you said, or entry vehicles is also something I think which is definitely on the radar also of OEMs.
I see. Okay, in your case, custom cells?
Yeah, for us, it's simply kind of a diverse portfolio of different materials. So whenever we go into mass market, it's a very similar approach than what you just discussed. When we, for example, look into aviation, it's completely different. So we're talking about significantly higher performance parameters like C rates of 15 to 20. So it's far away from what automotive does. That obviously asks for different materials. So that's a different approach. It's also a different affordability in terms of cost, simply speaking. So the BOM is a different one, obviously. But I want to add another aspect, which is not only innovation comes out of materials. Yeah? Another aspect is, for example, we also go into processes. So, for example, we have now elaborated something like 3 years in manufactured cells and pre-lithiation. So that's a booster technology you can actually use for some base chemistries. It works well. For others, it doesn't work well. You need to kind of have a look into it. But for some of the chemistries, it's kind of really a booster, for example, cycle life, or it's a booster for energy density, etc. Yeah, and these are, for example, technologies we very much focus on and try to also innovate, especially on the manufacturing side again. Yeah? So back to the first point, if you introduce a new technology or new materials, you're usually kind of confronted with a question like, how do you manufacture this? And some of the old processes work, and sometimes, especially if you would like to kind of work on the cutting edge of technology, you need to go straight into new manufacturing. Yeah? So that's one part of it as well. And I wanted to emphasize last point on materials. That usually is not just a cell maker business. Innovation is very close collaboration with material suppliers and running iterative loops, like everybody in automotive knows hills, like Harper and the Loop. And I would call it like we're doing something like mill, yeah, materials in the loop, and then iterate and see how this works and sells, and then iterate back how we change the materials.
Okay.
Yeah, so I mean, I can talk about SVOLT, but maybe it's also representative for the Chinese market. I mean, we are on everything. So, I mean, we are researching everything, and then we industrialize according to the client's needs. We of course have LFP solutions. We have from mid-nickel NMC solutions to high-nickel NMC solutions. We are also on the advanced doping technology, so to say. We have pre-lithiated LFP cells. We can talk about silicon doping of the anode. We also have a research department on solid-state technology, semi-solid state technology. And one thing which hasn't been mentioned yet, so we also do research on sodium ion, and here maybe it's worth to point out a difference between a remarkable difference between maybe the Chinese EV market and the German, especially the German EV market. So I mean, when you talk to German premium OEMs, it's always about how do you bring up the energy density, the performance to the very limit. How can you reach this 800 kilometer, 1,000 kilometer of range? And the thing which is neglected a little bit is the cost point. So when you read the media in Germany, everybody is like, hey, you cannot afford an EV. Well, yeah, because I mean, you bring the latest tech, the most advanced tech in your vehicles, which makes it a little bit more expensive, right? And on the other end, and this is, I read a nice comment, so this is the new kid on the block, the sodium ion technology. I mean, we will see where it goes, but I mean, this is the thing to build a vehicle which is, worth $15,000. And I mean, okay, it doesn't drive 800 kilometers, but maybe 250, we will see. And I mean, for my wife, for example, she goes 10 kilometers to work and then back to the garage where she charges her electric vehicle. This is more than enough vehicle for 15,000, 20,000 euro. Who can do this every day? Perfect, perfect.
Okay, very good. And now we have another question from Anonymous, and the question here, of course, I mean, we do not have the crystal ball, but there is the question actually, how is the market changing overall? Yeah, and maybe we can keep this in mind. Is there a chance that in 10 years there are completely different companies operating in the battery industry? So trying to look a little bit in the future, because we're talking about strategies, perspectives, and trends. What is your view on this?
Yeah, I mean, my perspective is for sure there are a lot of companies growing. I mean, not only battery companies, but if you look at the entire EV market, I mean, especially if you look into China, like every day there's a new car brand, right? Also in Europe this is happening. We have a lot more coming up in the US. So obviously the market will consolidate. So we'll not only see a limited amount of car brands maybe also compared to today, but also a consolidation in the battery market. Why is that? Because having or being successful in the battery market is not only about having good products, but it's also about having a cost competitive pricing. And for that you need scale, right? You need scale on the one side to have control about your production cost, manufacturing cost, but as everybody knows, production cost is not really a big deal in a battery cell, right? The majority is coming from the materials. And even there you need scale, right? Nobody will give you a good price benefit if you don't have the scale advantages and even the power to do vertical integration one step forward to, on the one side, secure the raw materials, on the other side also secure the pricing. So I think we will see a significant consolidation, and I think the market will probably look different, right? So I think also if you look at, I mean, there was this morning the reference to Nokia. I think we will see a similar story, and even I think some of the combustion engine brands we've known so far probably will also be somehow replaced by pure EV brands in the future.
Okay, so big challenges to look ahead.
Yes.
Dirk?
Yeah, when I look back 10 years ago, so 2013, I was part of the BMW team. We launched the BMW i3 to the market. And I remember very well the battery sourcing, which was one of my key tasks actually as a powertrain responsible. And then I realized we were trying to follow kind of 3 years ahead, so 2008, 9, 10, we tried to follow how, especially in China, the battery manufacturers were sorting out and who's popping up and who's going back. And we actually kind of, looked at this at a regular monthly basis. So every month we kind of looked at the same chart. And every month it was like that 25%, so 1/4 of the names disappeared and new ones popped up every month. And then after, I think it was something like in the mid 2010s, it somehow started to first time consolidate, because technology became a little more mature. Some were able to grab scale, others not, and they simply dropped off. So we have seen something like a consolidation in the last years. And then in the very recent years, we saw a couple of new startups, like some of these are sitting here, kind of coming up with new technology. And I think we're now entering a new phase. I completely agree there will be consolidation. Some will make it, some won't. But overall, that is, I think, a general trend. So we see lots of, in automotive, the two revolutions happening at the same point in time, and the same thing is here. So technology is reiterating again and again and again. We're not where we should be with our battery technology. So there will be always the trade-off of the big ones being able to innovate quick enough, and the startups of grabbing enough share and enough money to actually establish ourselves. But one thing we have in common, all of ourselves finally need to be able to stabilize the manufacturing.
Nemanja and then
Yeah,
Dominic?
I fully agree with the two statements. I just want to add, and also coming to this question, so this disruptive phase is not over. So the question implies a little bit that we have a stable battery industry. And from my perspective, I mean, yeah, there was a lot of consolidation in the last 10 years, but we are still in this, in this chaotic, disruptive, exploding phase, and we are far away from having a consolidated battery industry yet. So this will take another 5 years to have this consolidation, and so the battery industry. So this is an automotive context here, right? So, but I changed to a battery company because a battery is more than automotive. Battery is battery, and you can apply it everywhere in stationary energy storage, in an airplane, and so on and so forth. And when you think about this prediction of having 3 terawatt-hours of production capacity installed in 2030, I mean, there's still a lot of room for disruptive changes until then.
Okay, and Nemanja?
I think most of it is said. I mean, I like how this Mr. Anonymous comes on every conference. You see it all the time. I don't know, it's some very smart guy. But anyway, just to add, like, process stability and scale is kind of reversely proportional to rate of innovation. That's just how the science works. And what I see, just to add, because everything is pretty much said, this process stability will imply incremental change. So we're going to see a lot of incremental improvements, 2% better, 5% better, 10% better. And then we're going to have a few niches at the beginning, which are going to be 2x, 3x better, which then will inevitably also become popular. But I think it's realistic to say before 2030, we're not going to have anything at scale, which is not already present today in some minor scale. So if you talk about solid state and all this is post-2030 era. And what we have to do now is really focus on incremental improvements of the existing technology while keeping the stability of the process, because that gives you the cost.
Okay, very good.
Maybe I add something. I'm aware, I would like to comment on this. Yes, there might be some disruptions, but I think there's one difference why the Chinese market is so much more mature than us. Because in Europe has been always waiting for the next big thing, right? We said there will be solid state, there will be high energy density, while the others, they just build it, right? They just scaled it. And this is why the market in Asia has such an advantage right now, right? They are just 10 years ahead of us, because they just said at one point, let's do it, right? Exactly. And right now, if you look at the cars, BEV cars in China are now at least the same price as ICE cars. We're not there yet here, right? So I think what's really important is to get it executed, right? And this is something where the European industry as such was waiting for, from my point of view, for too long to wait for the next big thing.
Yeah, I mean, this is also something in the opening keynote. We have heard this, yeah? So it's about we need to be brave, we need to be encouraged, but we have the tendency to be very afraid and, you know, not taking risks and so on.
Yeah, and maybe, I mean, maybe it was just an excuse to rely on the legacy business. I mean, maybe, you know, okay, hydrogen comes later, but I mean, maybe it's just an excuse to.
And on top of all that, sorry, just to add, it's really hard to make a battery. It's not like it looks like a simple process. A couple of raw materials, how hard can it be? It's a really hard process. Yeah. And therefore, you even more have to emphasize, just start doing it. You will make some mistakes, go, and in a couple of years, it's going to have a really good results. But like this, we wait for the next, and then we're over. The game is over.
Okay, so let's look at the next question. Again, anonymous. He is, you know, the person is always raising the questions. How important is connected software approach to gain data from the different development stages and manufacturing to increase efficiency and to reduce time to market, respectively also to cut down cost? Yeah. So this integration. You are nodding. Dominic, you want to jump in?
I mean, this goes a little bit in the product development side. So yeah, I mean, it's very important to have to build up huge knowledge, huge data value, so to say, of your products, starting from the pilot phase or pre-A sample research R&D phase. Going to the B sample, C sample, until when your vehicles are driving in the field, and also, I mean, there are second life approach where we rebuild batteries in vehicles for stationary energy storage and so on, and to collect all this data and understand how your cell is developing, aging. Under certain environmental influences. This is crucial to eventually invent a better new generation of lithium-ion technology. And here, I mean, I'm not an expert of the differences of data projection in China and in the European market, but certainly this hesitance, especially in Germany, to not having access to all the data, to not collect all the lithium-ion cells in one data pool and then analyze it, it's not helpful to improve the lithium-ion technology. And in China, this is done. So SVOLT, for example, we have a big data platform where we collect all this data and analyze it and use it for our simulations.
I would like to differentiate. So CUSTOMCELLS is having kind of a differentiated view on data. There's two different kinds of data. One is, very simply speaking, all the data you can actually kind of collect during the operation of your cells. Yeah, that's obviously very, very helpful. And also every OEM is looking into it because it is the source of truth. The second thing is all the data you generate actually during you develop and manufacture the cells. We actually use this very, very intensively for two things at the moment. So one thing is we just look back and see, okay, what can we actually change in terms of our manufacturing processes? And I promise you 90 to 95% of what we find is exactly related to this data. So it's the source of really understanding what we're doing right or wrong. And the other thing I wanted to point out is, very simply speaking, we're also trying to look forward. So we're now trying to combine data from operations and the manufacturing data and combine it together. And that, for example, helps us to make extrapolations for safety. So let it put this way. Whenever we see, for example, we try to analyze a couple of thermal events of tested or randomly happened thermal events and trace it back. And we realized most of it would have been foreseeable days before. Yeah, that's a very valuable information you can use in aviation. So that's, for example, what we do. And last statement from my side, if you ask me kind of, is this data, especially in manufacturing, valuable or not? I told you that CUSTOMCELLS, is profitable, especially in doing the very first steps. Taking a PowerPoint presentation of an OEM or something else and bring it to the very first cells. And I promise you, the physical cells are always most interesting. Yeah, seeing is believing, and I can measure it myself, of course. But the willingness to pay lies with, can I have the parameterization of the manufacturing?
Okay, and in your cases?
I just like to joke sometimes, batteries are a little bit like humans. They don't like too hot, they don't like too cold, they degrade if you misuse them, they get upset and so on. So the part of the software is actually really important, first fundamentally from the OEM perspective, but also from the user perspective. From the OEM perspective, they really need to understand what battery does and what it's capable of, and how to precondition, let's say, the circumstances, and how to actually use the energy more efficiently. And Tesla has proven that with multiple software updates. I can name 20, but that's not for this panel. And on the other side, users will also get used to it, because a used car will be valued also by the value of the state of health, we say, of the battery. So it's a new world. You cannot just refuel it and go. We still think about, most of the population thinks it like that. So there will be additional training needed also on the user end. So it's very interesting how this will play out.
Thank you, Nemanja. And in your case?
Yeah, I mean, data is extremely important to understand. Well, I wouldn't necessarily call it time to market. I would call it more robustness of your process, because until you really can have an impact on time to market, you really need to have field data and really validated data. For a startup or a new factory, that, sorry to say, that doesn't help you, right? Okay. But it helps you to understand your process. It helps you to understand what is the quality of your battery, right? The problem about battery manufacturing is not that you cannot measure correctly. The problem is that you have a problem in mixing and you see it 30 days down the road, or even in the car, and all the other aspects were okay, right? So it's really about combining these 3,500 parameters, trying to put some AI above it, and really feed it with data, right? And this is why so many battery cell factories in the past, and even in the past years, past 2 years, had to increase the aging time dramatically.
Okay.
Right?
Can you tell us a little bit the aging time?
Well, the aging is just waiting time. Basically, it's idling time, where they see, okay, you need to identify micro shortages which you cannot really measure, right? And even established battery cell OEMs had to increase it because they figured out, well, we don't find all the problems, right? And I think that's why controlling it via data and feeding it with a big data system is of utmost importance to go down into a really reduction again in aging.
Exactly, so very crucial point, of course. So I have another question here from the audience, which is looking again also at the production and recycling process, and the question is, what needs to change in order to improve the sustainability in production and also recycling? So if you would actually make some sort of critical evaluation, we have heard about the aging right now, so, and you have addressed recycling aspects, but if you would specify these are the things that we would need to change in order to focus on sustainability in production and recycling, what would be actually your recommendations, remarks on it? Yes, please, Dominic.
Yeah, I mean, to put it very simple, in the end, we have to give the CO2 implement or footprint, so to say, of a component or of a battery cell a price tag. If we don't do this, we will not be able to compete with, raw materials with a higher footprint, CO2 footprint, because they're manufactured cheaper. So the selection will always be to take the cheap material with a higher CO2 footprint. If you give the CO2 footprint a price equivalent, and you decide accordingly, as the EU regulation wants to put sharp starting from 2027 or 28. So this is an attempt to do this. Then we will get more sustainable, lower CO2 footprint products. It will not be zero from the very beginning, but it's the entry to reduce continuously.
Okay, so like a CO2-related bill of material or something like this to the...
Yeah. So the battery passport, which gives a CO2 footprint of this product.
Yeah. Okay.
Yeah, I copy on this. I think the major change which needs to happen actually needs to happen in our minds, because overall I still remember the phase like, okay, when we talked about battery recycling from an OEM point of view, it was always a discussion like, okay, first let's ensure the supply, then let's manufacture the cells, then let's manufacture the car, and then let's operate the cars, and when it comes back it's a totally different age. Yeah, we take care about it when the problem comes. Yeah, and I think we need to understand that at some point in time the entire recycling becomes part of our supply, and when we close this loop and really understand that this becomes part of our supply, then it becomes really sustainable. So I think it's mainly the key way of thinking. And the other aspect I wanted to kind of recommend for us is, very simply speaking, we very often tend to just reduce the entire sustainability discussion just to CO2 emissions, and that's it. But sustainability is much more than that. So if I look into, for example, 15 years back, and when we built in Leipzig the first plant with BMW, one of the side aspects was that we reduced the water consumption in one of these plants by 80%, which nobody beforehand was able to think of. Yeah, but if you just go after it and really try to make it happen, the innovations come. And then it takes maybe another 5 years to make it stable and reproducible, yes. But it's a matter of thinking and maybe to incentivize that.
Okay, thank you, Dirk. Nemanja.
I would slow down with adding, because I look at the timer, maybe we go with a couple of, I think they said it quite nicely. So.
Okay. Sebastian.
I think we have some other interesting questions as well. Yeah.
Okay. Fine. I guess we will not be able to cover all of the questions here. Yeah. We have covered a lot. Okay, let me just see. So do you want to tell us a little bit about solid state, or let's say also natrium batteries, because this is also something which has been raised here. So who wants to also, let's say, finalize on the let's say the ingredients, the chemicals,
I have an opinion,
yes.
actually. Okay, sodium ion, we will see. It's the new kid on the block, we will see. I mean, I wouldn't bet on it yet, but I mean, we have seen interesting products in China. Commenting on solid state. So solid state is a very important technology to pursue, to investigate, also for applications beyond automotive. We will certainly not see solid state immediately. We will see a semi-solid state, so with a polymeric gel-like electrolyte in between. This will enter the market before, but this is a bit my personal opinion now. So, we are talking about building a lot of plants now, and investing in an intensive footprint worldwide. And all these factories, I mean, I'm not an operations expert, you are much more, but they are based on the technology as of today, the conventional lithium-ion liquid electrolyte technology. And they will run for, I don't know, how long does a plant run? For 10 years, 15 years? I don't know. And well, I mean, are we going to invest now in 3 terawatt hours of fabrication facilities and then change the technology? I don't think so. So solid state will be, I mean, there will be a market for solid state, but it will be more niche and high price premium applications.
You all agree?
I mean, just to add, I mean, people are generally emotional beings, and they like to debate about things they don't know that much about. So you will always hear a lot of debate about solid state and sodium and so on. I do think it has a future, by all means. But at the end, what they want to pay and what they want to see on the street today is going to be incremental improvements of what we have already seen in Asia mostly. That's what's really going to happen. And the rest is...
There was just a question before. Do you think we will see natrium ion, so sodium ion batteries in the car? The fact is, yes, we already have them on the car in Asia. They are already on the road. But I think if you look at our customer behavior, it's also different, right? If you look at Asian car specifications, they typically don't care so much about fast charging. It's not so much about really final range. It's also about just daily usage and cost of the car, right? We always make, in Germany, we call it eierlegende Wollmilchsau with the batteries, right? We have huge requirements in terms of range, fast charging, and we have requirements in terms of lowest price.
Exactly.
So I think this is also a change in habit of how we understand the car, right?
Okay, thank you very much. So in order to close this, because we are running out of time, we are actually above the time. So our panel discussion had the topic or the title, Strategies, Trends, Perspectives for Battery Manufacturing, assuming that we would need to create some sort of strategy paper. We have addressed also the aspect of, we need to be more brave, have more enthusiasm, and, not being that afraid. What would be the bullet point? We have 4 bullet points that we can put on our slide, in order to become better in the future. What would be your bullet point, what you would say, okay, this is what we need to do?
Execute faster. I mean, drop a little bit this 200 pages of doors requirement sheet and implement in shorter circles.
Okay.
Half a year, 1 year.
Fine. Very good bullet point. Dirk, what is your bullet point on our slide?
The next combination of product and manufacturing innovation comes as a pack, and let's be the leader in this here in Europe.
Okay, very good. Nemanja, your bullet point on our strategy slide.
Focus, de-risk, execute.
Very good, very precise. And Sebastian?
Focus on speed.
Okay, excellent. I have a last bullet point, which is to say a big, big thank you to the 4 of you. Again, Dr. Dominik Lemke, Director Product Development, SVOLT Energy. Then we have Dr. Dirk Abendroth, the CEO of CUSTOMCELLS Group. Nemanja Mikac, the CEO of 11Es, and Sebastian Wolf, the CEO of PowerCo. A big, big thank you to our experts here.